It might feel like the rise of agentic AI has happened all of a sudden, but it has evolved like any kind of workflow or technology. In this week's video, we're looking at a range of platforms and their ability to automate the detection and remediation of data errors at an enterprise scale. So, this is from our Data Pro News edition from March 25, 2026. Sit back and enjoy.
Every data engineer knows the sinking feeling of a Monday morning pipeline failure. You build a stable architecture, and without warning, it shatters. The cause is rarely a massive system outage. Instead, it is brutally mundane. Over the weekend, a third-party marketing platform like Salesforce or TikTok quietly renamed an API field, added a nullable column, or dropped a timestamp. Your extraction script does not care about excuses. It simply fails. That single upstream change cascades, breaking downstream attribution models and leaving your business dashboards populated with missing source events. To stop this cycle, we have to look past job-level monitoring and build a self-healing workflow. We do this by pairing the Airbyte agent engine with the dbt Model Context Protocol, or MCP, server. Deploying this specific architecture allows your pipeline to perceive schema drift midstream and autonomously repair the damage, permanently replacing days of manual forensic reconstruction. Step 1 in this process is establishing semantic definitions. An AI agent cannot remediate an error in your pipeline if it does not conceptually understand the data it is processing. To give the agent that understanding, we use entity resolution. This is the process of defining abstract concepts, like what constitutes an active user, so they carry a consistent meaning across completely different platforms. This diagram shows how the Airbyte context store manages those definitions. It acts as a central, validated dictionary, ingesting disparate streams from Meta, Salesforce, and HubSpot, and simultaneously applying a unified active user label to all of them. If you skip this step or configure it loosely, the streams bypass the central dictionary and fragment into chaotic, irreconcilable paths. You cannot ask an agent to reason about schema changes if it does not know which customer records it is actually looking at. The quality and safety of your autonomous workflow is a direct, measurable reflection of the semantic foundation you provide. Once the semantic rules are set, we move away from casual natural language prompts and adopt spec-driven development. You provide the agent with strict, version-controlled YAML configurations, dictating precise goals like maintaining 100% schema compliance. Following these specifications, the agent sets at the ingestion layer, actively monitoring the data flow. When it perceives a sudden change in an API contract, it instantly quarantines the anomalous records to prevent downstream corruption. This continuous perception catches errors that standard systems miss. For example, the agent can easily detect a 50% drop in row counts, a silent failure that a traditional pipeline monitor would flag as a successful run. When an anomaly is caught, the agent connects directly to your logic layer through the dbt MCP server. This protocol translates a raw data error into actionable context. This network diagram represents your entire dbt project architecture. The MCP integration allows the agent to inspect this multi-tiered pipeline as an interconnected dependency graph, from raw inputs all the way to final reporting marts. Before writing any SQL, the agent maps the exact blast radius of the error. When a raw input node fails, the system traces the connecting lines, illuminating exactly which intermediate models and final output tables will be impacted. By analyzing the dependency graph first, the agent formulates an intelligent, targeted remediation plan, rather than guessing at a fix for a localized error. With the full blast radius mapped, the agent drafts the specific SQL required to evolve the destination schema and update the broken transformation models. At this point, enterprise governance teams usually raise a valid concern: the risk of an autonomous agent pushing untested code directly into production databases. To mitigate that risk, the workflow uses secure containment. The volatile, shifting code generated by the agent is enveloped and stabilized by a secure barrier that prevents it from touching live data. In practice, this barrier is the dbt Fusion compiler. It provides an ephemeral, sandbox testing environment where the agent's proposed SQL is validated locally. Errors are caught and resolved here, far away from production tables. This containment strategy is a core component of formal AI quality control. Autonomous actions require defined oversight boundaries, ensuring the system operates safely within the data infrastructure. This mockup shows the resulting enterprise audit log. Every autonomous decision is structured and recorded, detailing the exact trigger event, the dependency checked, the sandboxed test result, and the final action taken. Generating this transparent, structured trail is non-negotiable. It provides the exact compliance record your data governance board requires to approve autonomous execution. When you implement this architecture, the operational contrast is immediate. Instead of a disorganized stack of Jira tickets, your team receives a clean Slack alert confirming the schema drift was detected, tested, and resolved. The business value scales quickly. Your pipelines maintain their integrity, the marketing dashboards refresh without interruption, and governance teams have full visibility. To test this yourself, launch your DBT test environment. Connect a dummy API feed, and intentionally drop a column. Watch how the workflow reacts. You will see the cascading failure halt and smoothly reverse itself, effortlessly repairing the complex system in real time. By the end of the year, the productivity gap between teams manually fixing pipelines and those using agentic workflows will be massive. The deciding factor is your willingness to build this autonomous foundation today.
Hey, thanks for checking out the Data Pro Explainer video. Don't forget to give us a follow and check out the Data Pro News at datapro.news, which is linked in the description. And then why not head over to our school classroom, which is also linked below, to discuss this and meet other data professionals from around the globe.